Okay, so those are the SAR satellite missions that are up. Typically, the space agencies don't operate their own kind of open archive. So historically, all of the scenes have kind of gone to these other archives. So at UNAVCO, we have the InSAR archive. The Alaska Satellite Facility has a large archive as well. There's other initiatives like the super sites. These were dedicated kind of tectonically active areas. It was a group, it was an EU initiative to kind of bring all the satellite data for all these super sites together and provide them for the research community. Kind of go into details a little bit here with what kind of data is available at each of the archives and sort of the coverage. For UNAVCO WinSAR, it's primarily North America. For ASF, you kind of have this global coverage. They're a mirror of the Sentinel-1 archive, so all the Sentinel-1 data, you can get it from Sci-Hub or you can get it from ASF. The Sci-Hub has all the Sentinel-1, SLC, RAW, and GRD products. They also have all the other Sentinel missions, so Sentinel-2, Sentinel-3. They'll all be in there. Again, the super sites limited to the specific geographic areas, so we have volcanic super sites, so Hawaii, Iceland, I think Etna, and a few other volcanoes, and then San Andreas Fault, the North Anatolian, some of these other large earthquake tectonic areas. Somebody mentioned the ESA on-the-fly interface, so they allow you to go in and request any of the ERS or MVSAT data as SLCs, and you used to have to go through EOLSA, but they've kind of streamlined that. This figure here just kind of shows, this is a footprint of the UNAVCO, WinSAR, and also the super sites archive, so you can see that there's a lot of data for Europe and Asia for the super sites. The different satellites, I think blues, ALOS, greens, MVSAT, red's probably ERS or RADARSAT. So more recently, there have been InSAR archives. So people have been kind of bulk processing data sets. One of them was the ASF Griffin data set, the Getting Ready for NISAR. So that data is available through Vertex. This is just a little screenshot. If you go there, there was like a little, I don't know if it's still the beta products tab. You can see all the different areas that they've been processing data for. The Comet Lix is another interface. They have a portal that you can go in, and I haven't been there recently, but they have a generic map interface that shows the coverage, and then a browsable directory where you can go and download the data. The WinSAR has a InSAR archive, but it's a community contributed product, and there's not a whole lot in there. So the idea was that as you begin to make interferograms of your own, you're publishing papers, you can upload the data and get DOIs for the data, and then have reference in your paper for those. Hopefully it'll catch on. And then I guess GAGE is it's a tropospheric correction for your InSAR. I guess most of the InSAR stuff we're going to go over on Wednesday, show how to download these products, and then the links are here just so you can familiarize yourself and find them. And then for accessing the data, this just goes over what you have to do in order to get an account and sign away your firstborn child so that you can have the data. And so Sentinel-1 is about the only open data set. You just register and you can get it. And almost all the other data that you get, you have to write a proposal or make some agreement with the space agency, and it's kind of limited in scope. So anything else to highlight? So for ESA data, they have this EO single sign-on that you'll need. So that will work for your virtual archive for the super sites and also this ESA on-the-fly simple online catalog. But most likely you'll have to go to each of those 2 sites and get permission for downloading data. So once you find out which archives have the data you want and you get accounts there, then in terms of searching for data.
Quick question, for the ESA one, is there a limit on how much you can download, or do you need to have special approval before you can download the ERS or the InSAR data? Do you know that?
I got special approval. I don't know how it is anymore. I mean, back in the day, you could just go into
not on SuperSite, but it is for American institutions. There's different policy in the past compared to.
So the on the fly for the SLCs, I think anybody can go and get them. So this simple online catalog. I guess I can pull it up. So this is fairly recent. I guess it was back in the spring that they discontinued the EOLI-SA, and now they're making everybody kind of come through this interface. Right. So these are all the collections. You can see the different collections that are available. Yeah, I guess these are the ones. This one, level 0. Yeah, you can get level 0 and SLCs. It looks like. So good. Yeah, I don't know if there's a limit. They did say if you're going to do bulk, that this is the way you have to do it now. So the Simulsar Archive, it was a project between ASF, UNAVCO, JPL, and Open Topography, and it was to build kind of this. So ASF had their archive, UNAVCO had our archive, and we each had our own separate APIs. So you had to find different ways. You had different ways to search each of the archives. So this project created a federated API and a federated client where you can go to one interface and search for data at both of the archives. And we developed a web GUI interface and then also command line clients. So this page gives you details about the API and the various services. There's a simple GUI interface where you can use a bounding box and select an area. You can put in your parameters and do your search. This is helpful if you want to kind of do some exploring and see what kind of data is available, if there is data available in your area. Because if you notice, this footprint here, there's a lot of bare areas. So it's sometimes nice to go into a GUI. You can do a search and see where the data is. And then if you know the data that you want and you want to process it, this is where the command line client becomes helpful. So it's up on GitHub. You can download it and clone it. And this notebook just kind of walks you through downloading it and getting it installed on your notebook container. So if we run this, it'll clone the repository into your home work folder, and then it runs just the command, the federated query. And if you run it without any options, it prints out the help, so you can see all the parameters, how to call it. If you keep scrolling down, there's output results, so you can get KML, CSV, you can get DENs. We have an option to get the Sentinel-1 orbits, and then we have some example commands for doing searches. This example at the bottom was from years past. We had processed the NVSAT Baja earthquake data. So if we run this command line client, so we put in the platform parameter as NVSAT. You can specify relative orbit or track. So this is track 84. You can put in the frame. You put in start and end times and collections. So if you want to do interferometry, you have to have the same satellite with the same geometry on the same track. So the command line client is set up where you can put those in and get a specific InSAR stack in your search. So if we go back to Haresh's the strip map app example from earlier. So we had this alternative SAR command right here. So this has a download option if we just say print and run this command. Hopefully it's, oh, not found. Yep. Even right above it. There. So it runs the command. This is the actual URL to the web service. So if you click it, it'll show you the results that came back. So this found the two scenes. Another way that you could find the same two scenes, we could use the absolute orbit option. You can say dash absolute orbit or just -A, and you can put in the absolute orbit numbers. So this command will find the same two scenes, but I'm doing platform ALIS, specify the relative orbit. Instead of doing an intersection with a polygon, I'm doing an intersection with a point, and then I specified the two orbit numbers for the scenes, and you should get back the same two scenes. So unfortunately, ASF, you should be able to search on frame, but if you notice from the strip map naming convention, this is our orbit number, and then this is our frame. So if we come over here, we searched on orbit, but then this frame says 3230 in the actual name, and then ASF thinks it's frame 3202. So this has been in the last 6 months, because I started getting questions from people saying SAR was broken and this command that I used to run and I could find my data doesn't work anymore. So then it turns out they were using track and frame to find their scenes that they wanted from ASF. So when they put in frame 3200, they found 0 results from ASF because ASF thinks that frame 3200 is now 3202 or 3203. You can see that they're not even consistent between their two data sets there. So, yeah, I don't know what to do about that. ASF. So they like if you go and you look at their Sentinel-1 data, they've got these made-up frames for them as well. So my advice is if you're searching at ASF, you're going to have to use relative orbit and point like this to kind of constrain. So that's what I did when I did the search. Yeah, we need to do this. You can come back here, and you can copy all these over into the relevant fields here. Down here at the bottom, you can either draw in a box, or if you already know the geometry, you can just put in intersect. So this is WKT, well-known text notation. So you can have point, line, polygon, multi-point, multi-line, multi-polygon. Yeah. And we can put in the absolute orbits. Oh, so I didn't put in ALOS. So I found a TerraSAR X scene. I thought that would be enough. So you can see that there's a TerraSAR X scene with the same exact absolute orbit that covers that. Thought I was going to get clever and only get the ALOS scenes back. So if you put ALOS in as the platform, it'll do the search and get rid of the. So those are the two scenes that we got back. Yeah, there's TerraSAR X. Somebody was asking why we found the TerraSAR X. So there's TerraSAR X for this area. And I thought, what are the chances that there's going to be a TerraSAR X with that same exact absolute orbit? I guess I guess there was. So yeah, typically you would want to take all the parameters that you have here, platform, relative orbit, intersection, and absolute orbit. You'll get back the same.
You're not actually getting all the TerraSAR X data. You're just saying in the library there is a TerraSAR X. I mean, you're not actually querying the Airbus site to actually find all the archive that might be available.
No, not here. This is data that is available at archives.
Got it.
So there's another super catalog of all the SAR data available, but yeah.
UNAVCO has that? Or?
No, nobody has that. Oh,
okay. So like MDA just began publishing a WFS that we've been kind of hitting off to look at the RadarSat 2 coverage and stuff.
Yeah.
So I don't know, it'd be interesting to see if we could build a connection in here so you could at least show that this data is available.
Yeah.
So also EODMS, which is I think the NRCan site, right? That they publish all that stuff, but I think you have to get a count or whatever with that, right? Yeah, so I think you must have to be a Canadian government person to be able to see it, but I guess that's where all of it is. And I think there's several exceptions, though, where you can't get access, so they might be willing to open up the catalog just to see that it's there, and it's worth exploring.
I mean that's a helpful thing, because sometimes you go to a new area, and there might not be data available in the archive, but there is data available from sort of like DLR, this TerraSAR X. You can write these research proposals and get the data, but they might not actually be available from any of the archives.
Right.
So you kind of have to go to all the different space agencies and find.
Probably worth pointing out that TerraSAR X data that you showed is probably not available to most people either.
Well, it's super site, so anybody can
okay.
get it. Yeah, I mean.
That's a super. But a lot of things that come up in SAR are in the archive, but they may be tagged to a particular PI, and unless you're a co-PI on that project, you won't have access.
Yeah, so we kind of talk about that further up in this. But I guess one thing I do want to note is when you do a search and find scenes, there's this Gdal Translate command that is printed out, again, Gdal. And this will allow you to download from Open Topography an ellipsoidal corrected DEM. So they published a virtual raster, so this is a Gdal format, and they've taken we took all the tiles from SRTM, we applied the ellipsoidal correction, and then store them on the OpenTopo bulk raster site, and then created this virtual raster that tiles them all together. So with Gdal, you can give a Gdal Translate command with a bounding box that you want to this VRT that virtually describes and virtually merges all of these tiles into one. So then Gdal knows which of the tiles it needs to read on the fly to generate this DEM. So all the Gdal, this particular Gdal command spits out a GMT format, DEM.
So how would you edit that so it was a ICE compatible file?
I mean, you could run this, right? So that's the size of the VRT, that's how many pixels are in it. And it'll probably run for a while. Download the DEM and then, yep.
Yeah, if the SCAT has hard-coded the GMT format there, if you show the command again, if you just change that to NV and then that will download in NV format, which ICE understands, and then there is one script called Gdal to ICE XML, and that would create the XML file that
So just NV? Is it just ENV?
yeah, just NV, and V capital, yeah.
So we're just going to write over dim.grid. So when you do that NV, I guess it creates that HDR.
Yeah, and then you only need to run the command Gdal to ICE XML. XML.py -i I guess, that file. So it creates all the, now you can use that DM in your ICE processing.
So this one, the aux.xml is created by Gdal, but this one, dim, I called it .grd, but it's not really a GRD anymore. Whatever. So this XML here is the one that ICE needs, right? So, yeah, when you run the SAR command, if you do the dash download option, it'll download the data that's found by your search. So if it's from ASF, you'll have to have this password.config.py with your passwords in it for the different archives. If you do the --dem with --download, it'll download the data and the DEM. And if you're doing Sentinel-1 and you do --download --dim --s1 orbits, you'll get the data, the DEM, and the orbits. So then you can go and process. So this DEM, it finds the bounding box that covers all the scenes covered, or all the scenes returned by the search. So that's why you would want to narrow it down to just the track and frame that you want, run the command, download the data, and it'll get the DEM and the data and everything for you. So I guess homework is to try it out and ask questions if you got any.
You all know enough to make your own strip map into ferrograms now from scratch.
Yep.
No. I mean, we should be applauding you.
Yeah, as a homework, if you guys like, as Garrett said, you don't have to reprocess the the pair that we did today. You could use SAR to download data over your region of interest using LOS or other strip map data that are available to you, and then use the same tool to download the DM and use strip map app to process it. So that could be a nice homework if you like.
Yeah, if you do an earthquake, I'll show you how to model it tomorrow.
So this is one thing that people kept asking about, what are the satellites to go in there? So under usage examples on the GitHub wiki for the command line client, I've enumerated all the different satellite options that you can put in there. So yeah, it gets kind of confusing. You need dashes and spaces. How do you, the name for the satellite, so. All right, any questions?
Previous slides you mentioned about the atmospheric correction from online. How does that work?
You guys are going to go over that later in the week? The whole notebook
Okay.
dedicated.
Yeah.
I just wanted to introduce,
Okay. All right.
have it here where you can click on the links and stuff. So. All right.
It's nearly 5:30.
Yeah. I guess with that, we can end for the day.
Yep.
All right. Everybody online, we'll see you tomorrow at 9.
Tomorrow we will be doing a similar exercise with Sentinel-1. If you guys are doing homework, if you guys feel like it, you could go up to the download part of the Sentinel data set. You can just push the button here and head home. It'll happen in the background if you want to save time tomorrow morning. So that's something you guys should consider doing.
And for the online people, I guess I will send out the PDFs of tomorrow morning's paper exercise so you can print them out. If you're in the room, I've printed them out for you. Or rather, Melissa printed them out for me.
I also have another announcement. Just to remind everybody who's staying at the hotel, the breakfast there is not paid for. So if it's okay, we will leave at 8 a.m. tomorrow there because there will be breakfast here. So you'll have some time to have breakfast before the class. So I just want to let you know the breakfast there is not paid for. We should arrive here a little early to have breakfast here. Yes, if you have not signed up for Earth Data accounts, please sign up. In Scott's notebook, please sign up for that. You'll need that for the Sentinel-1 download. Yeah, do we want to demo that real quick? To be able to download ASF data, you have to go to Earth Data and authorize the app. I can demo, or you want to do that? I can do that. Real quick, for people who haven't registered. Not NSA.gov. You were, yeah. So what we would like people to do is once you've logged into URS earthdatanasa.gov, go to Applications, Authorized Apps. Then you'll see a whole list of apps. I have a whole bunch of stuff that I don't need, but you go into Approve More Applications, search for ASF. You need at least that setup. And it only lets you add one at a time. So I would say if you see anything ASF that you find relevant, add to your list of authorized applications. That will let you use your login and password to automatically download via SAR or any other wget script. Otherwise, you will have a valid Earth Data login, but you won't be able to download from ASF.
Yes, on the ARIA one. So you'll need this for the next 2-3 days. So please sign up for Earth Data access. The link is in Scott's notebook. This one, the urs.earthdata.nasa.gov link.